Yeah, if you're new, let me give you a brief context of what we are actually building. So this is a Redis clone with 10,000 lines of code, which you'll get nowhere on YouTube. And in this video, we are building a small part of it that is hash table. So I've made a little change in the plans, that is how I upload things. So I'm no longer going to upload 1 hour long videos. From now on, he'll receive 30 minutes episodes. Like, I think people are not willing to watch 1+ hours of videos. So the thing is, we are building hashtable.c. There are a lot of things. So we are going to be using some algorithms, that is hashing algorithms. There are two different types of hash we are going to build. And then we have index and find slot. So yeah, in this video we are going to build the hash table and things around it. So let's dive in. So the first thing we gotta do is this fnv1a hash. Let's build that. So first let me just explain to you what that is. fnv1a Fowler null wo hash. I hope I pronounced it right. I don't know if I'm right or not. And the version is 1a. Is a non-cryptographic hash function designed for speed and simplicity, making it ideal for hash tables, checksums, and data fingerprinting. So we're going to be using it for hash tables, nothing else. And yeah, here we got the implementation. So what we have to do is, first we have to store it in hash and all that stuff. So yeah, we are going to implement on 1 byte each. We'll understand that when we'll do actual coding. Yeah, so let's get started. So the first thing, I need to import everything, include, and then what we're going to need is common.h. And the next thing is, because it's a hash table, we'll need hash header file as well. After that, what the function receives and returns, I guess it returns unsigned integer 64-bit, and it receives a key which we can't change. So u64 fnv1a hash. Okay, it's not. And it's going to get something like this key. Then let's see what we have to do. Now before running the code, I have to define these things, that is the fnv offset basis and fnv prime. So it's standard 64-bit fnv1a offset basis used as the initial hash value. So yeah, this is going to be initial value, which then it will change according to the byte. And then here we have prime, which is used to mix the hash after each byte. Let's define those. I'm just going to copy it and I'm going to paste it on top here. Same with the prime. I'm going to copy it and I'm going to paste it here. So the first thing we ought to do is we have to get the length of it. So let's do that, and then create a hash. I got that. Let's get the length. So size t length and str length, and then pass the key. Then I have to get the hash, and just a second, 64 hash. So now we have to store this fnv offset basis in this hash, which is going to be initial. So fnv offset basis. Okay, now what we have to do is we have to loop through each character in the key, convert the current character to unsigned char, and then cast it to unsigned 64-bit. Gotcha. And then we have to do XOR operation. Let's go. Hash. I don't know why I'm so excited. Hash, and then we can do something like this: use 64 unsigned char and then the key, something like this. So okay, for size t, I is equal to 0 if I is less than length, in that case I plus plus. And yeah, something like this. Let's take this up and like this. Simpler way or more smaller way to do this is like this. So I'm going to be doing that, something like this. So that's what I'm going to be doing, and let me just remove this. Now the next thing we have to do is we have to multiply this. So hash multiply it by the FNV prime number, something like this, and now we have got the hash, so we have to return that hash. So that's it. Yeah, it was just like that. So now our FNV1A version algorithm hash algorithm is done. Now the next algorithm which we have to build is this one, which is the DJB2 hash function is fast, non-cryptographic string hashing algorithm created by Daniel Bernstein, primarily used for hash tables and dictionaries, operates by initializing and so on and so forth. And here we have got how to use it, some little example of it. So yeah, that's how we have to do it. Let's do it. Its default hash value is different, it's 5381. Okay, now the next one, DJ, is going to return the same, use 64 and 64 djb2 hash. It's going to receive key, and then what I have to do is first I guess I have to get the length. Let me just copy this. Okay, I'm going to copy it and paste it over here, even though it's not going to be same. Here we have 5381 if I'm not wrong. Let's check it out. Yeah, it's 5381. Then convert the current character to unsigned character, then cast it to 64 bits. Yeah, I'm going to remove this. Then here u64 current character, now it's going to be u64 but first it's going to be unsigned char and the key, something like this. And then we have to do some multiplication, convert the character. Yeah, we did that, multiply by 33, and yeah, this thing. Yeah, so I've got this. So what it does is let me just copy this first. So yeah, what it does is it shifts every bit to 5 steps left, and then like it's like multiplying hash with 32, and we are adding again one hash, that is 5381. So it's like so this thing is equal to this 5381 multiply 33, something like this. So that's why I've did here. So you can multiply the current hash by 33 and the current hash, add the current hash to the hash, repeat until all character process and return. So then we have to add this current u64 unsigned 64 bit, and then yeah, that's what we have to do. And then we have to return the hash. So we've built both the algorithms, both the hashing algorithms. The next thing which we have to build is probe next. Size t is going to return an index and capacity. Size t probe next, it's going to get index, and I guess it's going to get capacity, right? So yeah, capacity. These are the two things it's going to get. Check if the capacity, if the table capacity is 0. What the fuck am I getting? Yeah, capacity is 0. If the capacity is 0, return 0 to avoid division by 0. Add 1 to the current index and use a modulo operator with the table capacity. Store the result as the next index and result return the next index. Yeah, that's what we have to do. Let's go. If capacity is equal to 0, then return 0. Otherwise what you have to do is we will get the next index. And how we are going to get that? We have to do index plus 1 and then use modulo operator with capacity. So that's how we'll get the next index, and we have to return the next index. That's it. Our probe next is also done. So the next thing is find slot. So yeah, we have to build a find slot function which gets table, key and hash and returns hash entry. Let's go. Hash entry pointer to hash entry. So it's going to return address to it. Nothing else. Find slot. Find slot, it's going to get the hash table, something like this. It's going to get key and the hash. So I don't think we are going to change the key. Let me just check. Yeah, we are not touching key. So yeah, that's it. and then we are going to get use64 hash. So I think for the first thing I gotta do is I have to check whether these things are actually there or it's nothing. So let's check that. Check if the table or key is null. Yes, so let's do that. If table is equal to null or key is equal to null, in that case we don't have anything to do. So I guess I just have to return null. Yeah. Then check if the table has allocated entries and a valid capacity. Compute the starting index using hash and capacity. Yep, got that. If table entries in, so if entries in table is equal to null or table, so I think we have, where is my hash dot h? Yeah, let me just check the hash table. So we have capacity and hash table, so we have to check. Now I have to check if table capacity is equal to 0. In that case we don't have anything to find, then return null. So check if the table has allocated entries and a valid capacity. Okay. So now we have to get the index, so size t index, which is going to be something like this, hash modulo capacity. So we'll get the index like this, then initialize the visitor counter and the first tombstone. It's something like this, table capacity, and I don't have to leave spaces here, something like this. Now that we have got the index, we are going to store the visited entries as well. So visited is going to be 0, and we are also going to store the tombstone, so it's going to point to hash entry. So first tombstone, something like this, which is going to be null for now, something like this, and then we loop until every slot has been checked, get the entry at the current index. Okay, let's do that. Now how am I going to check? So that's why the visitor count we have. So what I have to do is, if visited, just a second, visited is less than table capacity, then we have to run the loop. Okay, now we have the index, right? Then we have to get the hash entry. So the first entry, we are going to store the address, so I have to do something like this, table entries and the first entry. So the entry on index, not the first entry, but the entry which is there on index. Yeah, now that we have to check whether it's empty. If it's empty, return the first tombstone if one exists, otherwise return the empty. So yeah, what you have to check is if entry state is equal to empty. In that case we have to check if first tombstone is not equal to null, then we have to return first tombstone, otherwise we have to return the entry which is empty. Okay, after that, if the entry is occupied, compare the hash. If the match, compare the key using, yeah, I know that. So next we have to check if entry state and what's there, occupied is entry state is equal to occupy. In that case we have to check if the hash is equal to entry hash, and if it is, then we have to check if key, so c what's that, cmp, and if we have to give the key, so we have the key, and the next key is entry and the key, something like this. So if it's not equal to, if it's equal to 0, that means it's matched. In that case we have to return the entry. After that, if it's not even occupied and if it's not even empty, that means it's a tombstone. In that case I don't have to do anything, I just have to store the first tombstone and then I have to get the next index and increase the visited count, I think. Yeah, so return the entry. If the entry is tombstone and no tombstone has been saved yet, remember it. So if entry state is equal to tombstone and first tombstone is equal to null, in that case I have to store the first tombstone will be equal to entry, and then we have to get the change the index. So how we are going to change that, we have built a function for it before. So this is the one for probe next. So is it probe next? Yeah, it's probe next. Let's call that probe next, and we have to give it current index and the table capacity, something like this, and then we need to increase the visited count like this. So we are done, and the last thing is we have to check if first tombstone is not equal to null. In that case return first tombstone, else we have to return null because we have found nothing, no tombstone, no empty, everything is completely occupied and the key is also not there. If the tombstone, yeah, we did that. Move to the next index using probe next, increase the visited counter. If the loop finishes and a tombstone was found, return it, otherwise return null. Now find slot is also done. Let's build this last function, that is rehash table. Rebuilds the hash table with a new capacity. Let me just check what it does before doing anything. It returns bool, it takes table and new capacity. It returns boolean. So rehash table, it takes hash table and it also takes capacity, I think, new capacity, and let's see what it's going to do. Check if the table, okay, if table is equal to null or new capacity is equal to 0, in that case, just a second, in that case I have to return null. No, I don't have to return null, actually I have to return false. Check if the table has allocated entries. So we have to check if table has entries. So if entries is equal to null, that means there is nothing, there's no entries in it, so return false. Yep, return false. The next thing we have to do is ensure the new capacity is at least the current table size. Check for allocation size overflow. Create a temporary hash table. Let's go. What do you have to do? Ensure the new capacity is okay. If new capacity is less than table capacity, in that case return false because we can't rehash it, we can't do that. And then check for allocation overflow. If new capacity is greater than size max divided by the, no, it's not like that. So how it's going to be, check for allocation size overflow. So what I have to do is I have to divide it by the size of hash entry. If it's greater, that new capacity is greater than size max divided by hash entry, that means it's going to overflow, so I have to return false. After that what we have to do, create temporary hash table. So let's create it, hash table and no temp temporary table, and let's create it malloc. So should I use malloc or what? Initialize okay, allocate memory for the create a temporary hash table. So it's going to be temporary here. So let's do it something like this. Temp table, and then allocate memory for the new entry, array. So hash entry new entries, and how we are going to malloc the new capacity multiply size of hash entry, something like this. So if new entries is equal to null, then I have to return false. Otherwise, let's see what we have to do. Initialize initialize the new entries with 0. So I think I should call lock here rather than malloc, so it would be more easy. So it will initialize all that with 0. Or if you don't want to use call log, then you can do something like this. So you can call memset. I think that's what it was, memset. So it takes destination, which is new entries, then value, which is 0. We have to put 0 0 everywhere, and the size, which is new capacity multiply size of hash entry. Yeah, something like this. So we have so we've put 0 everywhere in the new entries. So before it were random bytes, so now it's all 0 0 0. So it becomes, somewhere it becomes null, it becomes false, and somewhere it stays 0. So it's something like that. Initialize the temporary hash table. Okay, so what we have to do is temp table. So what we have inside it, we have capacity, which will be equal to new capacity. Then temp table, we have entries, which will be equal to new entries. What else do we have? We have size, tombstone. Let's put size as well, which will be equal to 0, because there's nothing now inside it. Okay, something like this. Then I have initialized the table. So loop through every entry in old array, skip empty and tombstone entries. So what I'm going to do is, if now we can't, let me just do it first. So for size t I is equal to 0, if I is less than table capacity, then we have to do I plus plus. Now why the heck I'm doing capacity here? So why I'm doing table capacity instead of table size? So the reason behind that is something like this. So we have something like this. So here 0 means empty, and if there's anything but not 0, that means it's there is key there. Okay, so it's something like this. We have, let's say the table is something like this. As you can see, we don't have the key values in a proper order, so they are anywhere in the table. So it's first empty, then second is empty, then the third value is key, then the fourth value is again empty, then the fifth value is key. So we can't do it for size. So what will happen is, if we did for size, we'll just check for the first three, let's say. Or if the size is 3, if the size is 2, we'll check first 2, and they both are empty, so we won't get any key. So that's why we are using capacity, so it will search the whole table. Now what we have to do is, we have to check empty and tombstone entries. So so we have to get the entry, hash entry. So table entries, and then I have to give the index, that is I. Then here I have to check if entry state is equal to empty, or entry state is equal to tombstone. In that case we have to do nothing. We have to continue with the next index. Then we have to find the correct slot in the new key using find slot, copy the hash. Okay, then we have to do one thing. We'll get new entry. Okay, now we have to get the slot where we are going to put the key. So let's get that. So new entry, and then we are going to run find slot function. For that we have to give the table, we have to give the key, and we have to give the hash, which we will get from here. Entry something like this. Yeah, this is done. So do I have the key? No, so we don't have the key here. So the key is inside the entry like this. So I have to give the table, I have to give the key, and I have to give the hash. Find the correct slot in the new table using find slot, copy the hash key value and state into the new slot, increment. So once we'll get the new slot, don't I have to check it? Like, yeah, we do have to check it, right? So if entry state is equal to occupied, in that case we have to check. Okay, let's not do this. Let's check if empty or tombstone state is equal to tombstone. In that case, verify that all occupied entries were copied. Okay, the next thing we have to do is, if it's empty, we have to copy everything. Skip empty. No, not this. Okay, we are skipping. Okay, now if not entry, actually new entry. If new entry is empty or tombstone, so that means we have to insert copy hash key value and state into the new slot. So I have to copy everything. So let's copy it. New entry dot key, which is going to be equal to entry key, and just like that. So we have here address, so we can't do something, we have to do something like this. Okay, we have to do something like this. Yeah, now I have to change, I have to do your hash. Actually I have to do here value, not hash. Here also value. I forgot to add this one. Now let's just add the hash as well. And the last thing which we have to add is the state, which is occupied. So we have to copy everything. Now if it's empty and Thompson, we have to copy everything, otherwise it's occupied. In that case we have to check. There's something wrong here. New entries. Okay, I've got the entry. Continue. Otherwise, so I have to pass here the temporary table, I guess. Yeah, I have to pass the temporary table, actually not this one, the temporary table, and the key and the and that. Then I have to add, then I'll get the entry, and then I have to add everything. If entry is empty and tombstone, then we have to add it. Then I also need to check if new entry is equal to new entry state is equal to occupied, and if it's occupied I have to check. If it's occupied, then I have to continue, I guess. Then yeah, then we have to continue. So we have to add it only if it's find the correct slot in the new table using find slot. Yeah, if slot is empty, it's not there actually, but yeah, increment the new table size. So I have to increment the table size, but that will happen here. Table. So temporary table, actually temp table size plus plus, verify that all occupied entries were occupied, free the old array. So after the loop is finished, here I have to check if temp table size is equal to table size, then I need to free the table entries and replace the old entry and return to. So if it's not equal to table size, then return false. But before returning false, I have to free the new entries, and then I have to return false. Then here I have to free table entries and then put new entries inside table. Entries will be equal to new entries, and then I have to return true, something like this. Replace the old table's entries capacity. Yeah, I have to check with the new ones. So we have to change the capacity as well with new capacity and size. So let's change the size as well. So it's going to be table size, which we have inside temporary table. So yeah, I have to use temporary table. And yeah, so hash table is also done. We have wrote 156 lines of code, and yeah, it's done.